Today we're going to talk about systems of linear equations and graphing them. Now what a system is of equations is basically two or more equations. And if we've got two linear systems, which means two equations of lines, then the solution of that system is an ordered pair or an x and y point that solves both equations. All right. If a system has one or more solutions, then we call it consistent. If it has exactly one solution, it's called independent. Spelled that wrong. And the graph is going to intersect at a point. And if the system has infinitely many solutions, we call that dependent. And the graph has unlimited intersections. I'll show you what that looks like in a second. And if there's no solutions, it's called inconsistent. And the graphs or the lines are parallel. And you should know a little bit more about parallel from what we've already studied. So if we take a look at all these possible linear pictures, we've got exactly one solution, so that's consistent and independent, and it's intersecting at one point. If we have infinitely many solutions, then typically what happens is one graph is graphed directly over another. So there's infinitely many solutions. We call that consistent and dependent. Lastly, no solution, no intersections, and parallel lines will exist. So let's take a look here. And we want to take a look at this graph over on the right and identify the equations that they give us. So for instance, in this case, we have y is equal to x plus 2, negative x plus 2, that's this line here, and x plus 1, which is this line here, and talk about the solution, whether it's consistent, inconsistent, independent, or dependent. So we see that these two lines with the blue check mark intersect in one spot, which means it's going to be consistent. And since they only intersect in one spot, it is independent. Next, we'll take a look at negative x plus 2, so we'll use green this time. And 3x plus 3y equals negative 3. These two. Now if we look at these, they appear to be parallel and never intersecting. We could probably take and find the slope, go down 1 over 1. This guy goes down 1 over 1. So they are parallel lines because they both have slopes of negative 1. This means since there's no solution, they're inconsistent. And finally, let's use red. If I can find red. So in red, we now have this 3x plus 3y equals negative 3. And this negative x minus 1, which is right here. And we notice that, hey, wait a minute, these are the same line. So it graphs on top of itself, which means there's infinitely many intersections. So we say this is consistent and dependent. So that's how we classify all those. Now we're going to take and actually find some intersections by graphing, and you'll probably need some maybe graph paper to do this fairly accurately and find the exact intersections, so you'll at least have to know how to do it accurately on a test or a quiz with graph paper provided. So they want me to graph the system and determine the number of solutions it has, and once I've done that, we're going to name the solution if it's got any. So I need to put these in slope-intercept form. I'll subtract 2x from both sides, so this is y is negative 2x plus 6. In this case, I will add 2 and add y, so I end up with y equals 2x plus 2. I get from adding 2 and adding y to both sides. So in doing that, I'm now going to graph these. We'll do this top one in red. I go up to 6, go down 2 over 1, do that a couple of times, connect the dots. And we'll do this next one in blue, go up 2, go up 2 over 1, up 2 over 1, connect the dots. And we can clearly see that it has one solution, and that solution is the point 1 and 4. And you'll find that if you plug 1, 4 into x and y in both equations, it will solve both. And let's just do that. So that's 2 times 1 plus 4 equals 6, and sure enough that's true. And then I have 2 times 1 minus 4 equals negative 2, and 2 minus negative 4 is negative 2. It solves both. So in this next system, we'll take and I'll divide both sides by 2. In the top equation, bottom equation is already in slope-intercept form. So I have y is equal to negative 2x plus 2. You'll notice that this equation is now the same as this equation, which means that the lines will overlap on each other. If I go up to 2 and down 2 over 1, down 2 over 1, etc., etc., you'll notice my line looks something like this. Like I said, if I graph the bottom equation, I'm doing the same exact thing. So one line is overlapping onto the other. Thus, we have infinite solutions. So what that means is any point on this green-blue line is a solution to the equation. So I have infinite solutions of y equals negative 2x plus 2. So anything that solves this will work. For instance, if I plug a 1 in for x, I get a 0 out for y. That works. I plug a 2 in for x, I get a negative 2 out for y. But I have infinite solutions that solve that equation. Next problem, what we'll want to do is get y by itself. I'll do this guy in green, the bottom guy in blue. So let's do the green guy first. I'm going to take and subtract 3x to both sides. So I have 2y is negative 3x plus 6. Divide both sides by 2. I get y equals negative 3 over 2x plus 3. Now I'll do the blue. Again, subtract 3x to both sides, which gives me 2y is equal to negative 3x minus 4. Divide both sides by 2. And get y equals negative 3 halves x minus 2. Graph going up to 3. Going down 3 over 2, down 3 over 2, puts me somewhere like this. Then we'll go down 2 and down 3 over 2. I can't really go down 3 because I don't have any more room, so I'm going to go up 3 and back 2, which also gives me that negative slope. Look at down 3 over 2. Connect the dots, and you'll notice these lines appear to be parallel. Since they're parallel, in fact they are parallel because you'll see I have the same slope, I have no intersections, so 0 solutions. So now you notice we've got a word problem, and it's broken down in the following. We've got a guy who's starting a business, and he figures out he has 2 types of problems he's got to figure out. One, what it costs him to run the business, and in this case it's 20 bucks, and then 50 cents to produce each dog treat, and this equation is going to describe that. And then when he sells them, he's going to sell each treat for $1.50 a pop, and that's the equation that describes that. Go ahead and graph this. Now you need to figure out the slope in each case. 0.5 is the same as a half. So that's the slope here. 1.5 is the same as 3 halves. So that's equal to the slope for the second one. Y-intercept is 20. Go up 1 over 2 throughout. And in this case, I'm going to find y-intercept. That'll actually be at 0. And I go up 3 and over 2. And up 3 and over 2 again. And you'll notice it just happened to fall right on the line. So there are my 2. And they wanted to know when we're going to break even. And we break even when my number of dog treats, okay, equal a total of $20 in sales, all right, and the cost in cash, or these are the dog treats, is 30 bucks. So at 20, 30. 20 being the number of treats, and the dollars made. So in this last problem, we're going to use a calculator to try to graph our system of equations and get a point of solution. Prior to doing that, we'll take and set this up so we can graph in slope-intercept form. And in order to do that, in this first problem up top, I'll need to take and subtract 3x to both sides. So we start by having 8y equals negative 3x plus 32. Divide by 8 to both sides. And I get y equals negative 3/8x plus 4. Likewise, in the bottom equation, I'm going to subtract x from both sides, so I get negative 3y equals negative x plus 27. Divide by negative 3 to both sides. Notice I'm doing it to each term. I get y equals 1/3 x minus 9. So now we go to our calculator. And in the calculator, what I'll do is I'll go to y equals. And I've already plugged these in for you. So you want to type a negative. Anytime you have a fraction, you're going to have to make sure that you put the fraction in parentheses. There's my x plus the y-intercept of 4. The 1/3 in parentheses again, x minus 9. Now what we're going to do is we're going to graph this in the standard window. So we do that by hitting zoom and 6 for standard. And what it'll do is it'll go ahead and graph that. But you'll notice that I can't see an intersection, which is not a good thing because we want to find out where that intersection is. The reason we can't do that is because my window is not big enough. The standard window goes from negative 10 to 10 in both the x and the y. Now if I want to see further to the right, what I'm going to need to do is adjust my window so that my x is much bigger. Let's call it 30. So once again, hit window and then change your x max to 30. Go ahead and graph it again. And you'll see here that there's my intersection. Now I have to calculate that, and we do that by going second, and right above trace there's this thing called calculate. So hit trace, and we want to look for an intersection 5. So I hit 5. Then it says go to the first curve. Well, I'm on that, so I'm going to hit enter. Go to the second curve. I'm on that. I'm going to hit enter again. And every time it'll give you a guess, which really does nothing. And then hit enter for the third time, and it calculates my intersection point, which is the solution of both. The drawback to using graphs is that you get these decimal approximations. And if I did this algebraically, I could find the exact fraction where those intersect. But we're going to use a calculator for now. So we'll just say our solution is the coordinate of 18.53 for the x. And then the y, once again, was negative 2.88. And that point will solve both equations in this system. So I'd like you to write your lesson summary and do these problems below, and we'll discuss this more tomorrow.